purpose of this video is to be a bit of a consolidation to the initial activity on concavity and points of inflection. So during the activity, you were asked questions about a number of graphs. This is the first graph. I think it was also the graph for question 3. And in this question, you were asked how many points of inflection there are. And maybe it's helpful if I add a tangent line in, which I'm going to do right now. So there's my tangent line. I'm going to move it all the way over to one side and then the other. And you can see this tangent line over here is above the curve. So when this happens, we say the curve is concave down. And you can kind of see, if I was to trace this, and I noticed in the other video I didn't trace it maybe as slowly as I could have. And if this kept going, it would kind of keep going down like this, which would give us a downward parabola shape. And that's not what we have here. We don't have a downward this is obviously not a parabola, but this section kind of is like a downward curving shape. And we can see the tangent line is above. Now, if I keep going and going and going, you can see the tangent line gets very close to the actual average rate of change of the slope. And right around here, they're basically equal, which is a good hint that there's a point of inflection. Then after that point, the tangent line switches to being below. When this happens, we say concave up. So, and again, I can trace this. See, this is like if I continue this shape, it's going to kind of go up like this. So that means somewhere in this general location, there's a point of inflection. And I'm actually going to add the exact point. You can see it's right there. And watch what the tangent line does. Goes from below, above. So that's how we know there's a point of inflection. We're going to learn an algebraic way later. For those of you that want a bit of a head start, at this point, the second derivative is equal to 0. Now, later on in the question, you were presented with these 2 points, which I called point 1 and point 2. And the question was, what is the concavity at point 1 and point 2? And there were lots of options. I think I gave you every possible option. And so I'm actually going to add in some colors, just to kind of show the difference. So in the first section, the red section, this is considered concave up. The tangent line is above the curve, and the red curve, if you kind of imagined extending the trend, it would be a downward parabola, upside down U shape. And in the second section, you can see the tangent line is below the curve, meaning that it's an upward U shape, so it's concave up. And I can add those labels in right now. And that was basically the beginning. So now I'm going to move on to the next graph. The next graph was this one, and I discovered that while it was good for appearances, that when I was actually going around to make this video, I realized that the scale wasn't the best for that. So I'm going to adjust the scale. Go. And this might make it a little easier to see. So here again, you can see the tangent line curve. Right in this section, maybe that's not the best. Let's try 1.5. There, that's better. You can see in this section, the middle section here, the tangent line curve is above the tangent line is above the curve. But as I go further out on this side, the tangent line is below. And if I go over on this side, the tangent line is below. And right in this section, you can see the purple line is very close to kind of following the actual curve, which probably means there's a point of inflection there. And the same over here. And in fact, the actual points of inflection are at these 2 points. And if you watch the tangent line, it goes from below to above, which tells us a point of inflection. Later, you're going to do algebra and learn the second derivative would be 0 here. And then if we continue, we're still above, so second derivative, and then, never mind that. And then now we're below, which again means at the second point of inflection, the second derivative would be 0. But you can see that this section would be concave up, this section would be concave down, and this section would be concave up. And I didn't label that on this one, just for time, but I'm going to move on to the third one. Some crazy polynomial function or rational function. If you're curious, I think this was similar to one of the ones some of you had in the assignment. This is 0.1 x minus 2 cubed over x plus 1. And then I put a plus 10 at the end just to shift it up, because I find it's easier to look at these if you don't have to deal with the x-axis so much. So same question, except now I gave you 3 points. So I think there were a lot of different possible answers for this one. So this one was probably the hardest one on the entire assignment, or on assignment, I apologize, it's not assignment, on the entire activity. And sorry, here we go. If I move my tangent line, you can see it's below through this whole section. All of this section is below. And this is kind of like an upward U shape, meaning this whole section is concave up. And I'm going to change the color of that section. The next section, I'm going to move over to the next section. See, the tangent line is above the curve, and the tangent line is still above the curve, till somewhere around here. And then it goes below, not a lot below, but it is below. So, but in this section at point 2, it's hard to get exactly, that's pretty close. You can see the tangent line is above the curve, which is why this second section is concave down. And I apologize, I didn't actually show, I just realized section 1. I'm going to go back there for a second, right to point 1. And again, you can see the tangent line is below the curve. And I could zoom in so that you could really see that. Give me a sec to get it back. There we go. Back to the right zoom. And so tangent line's below, concave up. And you can see it's also kind of an upward U shape. This is like an opening up. It's a weird parabola shape, but it does open up. So it's definitely concave up. Whereas in this section, it's below. And then in the final section here, the tangent line goes below. And this is a very slight curve, but you can see it comes down. And if I was to continue the trend, it would then come up like this. So that would get us into a concave up scenario, which is the last one. And this is another way to come up with where the point of inflection is. So I'm going to add in some color, red and blue. And I'm going to get the tangent line out of here. And so based on this, if you look at the vertical asymptote, the concavity changes, but that's not a point of inflection, that's a vertical asymptote. But right around here, the concavity changes, which means there is also a point of inflection at this point right here. And that is kind of a summary of the activity. For those of you that got all the questions right, that's great. If you didn't, hopefully this video helps. If you still need additional help, please do not hesitate to contact me.